transfer of current. Current can be transferred from one place to another place under two circumstances or two conditions. For example, let's say this is the place where electricity is generated. You can call it, it is the generator, or it is the grid station where electricity is being produced. So I'm calling it generator. Now we need to transfer this energy to the consumer who will be using the electricity. So this is consumer end. Now to transfer electricity, we will be using, because electricity cannot be transferred wirelessly, right? I mean, nowadays there's a concept of wireless charging, but if you look at that mechanism, you need to put device in contact with some charger, right? So that is not truly wireless charging. What is truly wireless? For example, if you have seen solar cells, how solar cells are charged, they get energy from sunlight, they convert that into electricity, and then they get charged. Now, when I say wirelessly, I actually think of this kind of charging where you don't need to connect anything to anything. For example, if your cell phone is in your pocket, it keeps on getting charged. This is the idea of true wireless charging. So when electricity is transferred, we surely need some wired connection. So let's say we have a wire connection between generator and the consumer end. And this is that wired connection. Now this generator produces, let's say, 100,000 watts of power. It generates 100,000 watts of power. So what we want to transfer exactly 100 watts of power to the consumer end. So we don't want any power loss. We don't want this wire to cause any power loss when electricity is transferred from generator to consumer end. Remember the equation? P is equal to VI. So it means that when this 100,000 watts of power is generated, there must be some value of potential difference and there must be some value of current. Let's say the value of potential difference is 5,000. The value of current is, let's say, 20. Okay, if I multiply these two, what do you think? We will surely be getting 100,000 watts, right? So when we have this much voltage and this much current, we will be having 100,000 watts of power. Now, if you remember the formula of power loss is generally given by I square R, which actually tells us that power loss is directly proportional to square of current. The more value of current will cause more power loss. The less value of current will cause less power loss. So what we want to do? If we transfer this 100,000 watts of power under the combination of 5,000 volt and 20 amperes, since the value of current is very large, we will be having an enormous amount of power loss. So what we try to do? We try to increase the voltage so that we can reduce the current. For example, we increase this voltage to 10,000 volt. So we will be needing just current of 10 amperes. So I hope you will agree. Under this condition, the power loss will become 1/4. Why 1/4? Because we reduce the current to half. We have a square on the current in equation of power loss. I'm talking about this relationship. So when we halve the value of current, the power loss will become 1/4. So it means that if I transfer electricity under the condition of high voltage and low current, I can minimize the power losses. How many of you are actually getting this idea? To minimize the power loss, potential difference should be more and more and current should be less and less. Yes, Miram, Alan, are you people getting it? Okay, we can do one more thing. Let's say I further increase the potential difference. I increase this potential difference to, let's say, 100,000 volt. I will be needing just 1 ampere of current. So power loss even will be lesser. Such a wire in which current is very small, potential difference is very large, such a wire is known as high tension cable or high tension wire. Quite possible many of you might have seen, if you have traveled on any highway, even in UAE, you will see very tall or high poles with which some wires are connected, and the height of those wires is actually very large. Why? Because when we have high tension cable, it will be generating a magnetic field around it. If the height of these wires is small, quite possible anything which is passing below them feel the impact of electromagnetic attraction or force. So we keep the height of these wires very high so that the object doesn't feel any impact of magnetism. Anyways, so such a wire in which we have very high value of potential difference, very less value of current are known as high tension cable. And what is the advantage of it? Using this technique, we can reduce the power loss because power loss is directly proportional to square of current. But now this technique will impose a problem in front of us. And what is that? All the electrical appliances that we use at our home needs how much potential difference? If any one of you can answer.
Very less.
Any estimated value?
2 to 6 volts.
I guess you're talking about electronic devices because they use chargers and they are usually around 5 volt generally, right?
Yes, sir.
The voltage that comes to your house, I mean, every one of you must be sitting in some room and you must be having a power socket around you. That power socket must be having some voltage around 220 volt or 240 volt. The potential difference that comes to our houses is somewhere around 240 volt, right? If we are transferring 1000 volt of potential difference, it is a huge value in front of what we actually need, because we need just 240 volt, we just need 220 volt. Remember one thing, the appliances that we use, for example, you use a charger to charge your laptop, any digital camera you are using, your iPad, your tablet, your cell phones, you are using different gadgets. They need adapter, they need charger, and that charger is needed. Why? Because to charge a device we need a direct current. So the purpose of that charger is to convert alternating in current into direct current. This is the last part of this chapter, we will surely be discussing over there. But more important, we are providing 240 volt, but your device is charged at 5 volt or 9 volt only. Your device is being charged at 5 volt or 9 volt. Now, nowadays, this is the era of fast charging, right? I don't know how many of you are interested in gadgets and technology. Nowadays, you can charge your cell phone within 30 minutes. I mean, there are companies which are supplying 100-watt chargers with their cell phones, and you can charge those phones 0 to 100 in 30 minutes, in 40 minutes only. And 2 years back, 3 years back, you need at least 2 to 3 hours to charge a battery. Why? Because we are using fast charger these days. But what is most important, no matter what, that fast charger will be using 9 volt only or 12 volt only, but our socket provide 240 volts. So we need to decrease the value of potential difference at the consumer end. Same is true for the generators. Now, see, generator produce 5000 volt, the value written in blue color at the generator end. I change that value to 10,000 volt. How can I do that? How can I increase the value of that voltage? And even then, I increase that potential difference from 10,000 volt to 100,000 volt. It means that we need a device that can alter the value of potential difference. That device is actually known as transformer. That device is actually known as transformer. If anyone of you is fan of Transformers series, that has nothing to do with this transformer. So this device is known as transformer. Transformers are of two types. One is known as step up, other is known as step down. What is step up? Step up is the transformer that will increase the value of voltage. What is step down? A step down is the one that will actually decrease the value of voltage. So it means that at the generator end, we must be using a step up transformer. We must use a transformer here. That transformer is basically step up, right? And on the consumer end, we must be using a transformer that should be step down. That step up transformer as the generator and will keep on increasing the voltage to a very high value so that we can use high tension cable. And the step down transformer at the consumer end will transform that high value of voltage to very low value like 240 volt. And after that, it is on the consumer what potential difference he needs. He needs 5 volt, he needs 12 volt, he needs 16 volt, he needs 9 volt. He must be using an adapter. That adapter must be having transformer inside it, which is a step down, that will transform that 240 volt to 5 volt or 9 volt. That's why that fast charging is known as adaptive fast charging, because that charger recognizes the device and then it decides what potential difference it needs to provide, whether it is 5 volt, it is 9 volt. So it means that these chargers have multiple step down transformer inside them, which transform 240 volt to 5 volt, 9 volt, 12 volt to the lower values that we actually need. How many of you are actually getting it? What I tried explaining? Yasmin, Alan,
Yeah, I'm a
Amna.
bit confused with the part about the high tension cable and then the step up, which is at the generator, and the step down, which is at the
Okay,
consumer.
and what's your confusion, Mehan?
Yes, sir. This part about like
Yeah,
the voltage. Why does the step up have to be there and the step down has to be there?
see, because power generator generated just 5,000 volt. And using 5,000 volt current should be 20 ampere. And using 20 ampere current will cause so much power loss. We need to increase this voltage to a very higher value to reduce the value of current. Getting it?
Oh, so that we can decrease the power loss.
Yeah, so that we can decrease the power loss.
Mm,
Right?
yeah.
Okay. But by the way, how many of you are interested in technology and gadgets? I do ask this question in almost every class because in this class we have only two boys. So I'm not expecting many. Yes, Anas, are you interested?
Sir, partially.
Partially. Alan, any kind of interest in gadgets and all?
Yeah, it's like same as Hannes, like partially, like basically, if you say today or like nowadays, you're basically around 24 hours, like 7 to 8 hours, I'm on gadget because of online learning and stuff. So you have games and stuff. So yeah,
I
gadgets.
think this online learning actually gave students a way out. Now they can tell their parents we are on the gadgets because this is online learning. But I strongly believe for the past 1 decade, the entire generation is on the gadgets only. Now we have
Yeah,
an excuse.
but I think like we are fed up of it right now, like because of the
Really?
strains of eyes and strain of ears. Like I
You
think
you, you should
I really
you
miss
should
the
wear
old
blue.
school stuff.
Really? Yeah, school is
Yeah,
fun.
yeah.
No one can deny this fact. School is fun. But when I say interested, you know what interest means? For example, uh,
Yeah,
I guess eight
like
months back, 10 months back, I bought a charger, and on that charger, something is written like this, PD, right? And on that box, they highlighted this feature that this is a PD charger. You won't believe when I say who is interested, what interest actually mean. I Google it and I read so much about it to understand what does this actually mean. Not quite possible you must be having a charger which says it is a power delivery. PD means power delivery. This charger will be of, let's say, 100 watt, right? This 100 watt charger can charge a laptop which will be needing somewhere around 80 watts. This can charge your smartphone that will be needing just 20 watts. This charger can charge your smartwatch that quite possibly might be needing just 5 watts. These chargers are so intelligent that they see what device they are charging, and then they decide what outputs they should generate. So in these kind of chargers, we will be having multiple step down transformers in very small device so that they can decide what output actually they need to generate. So a step down transformer is something that we all of us are using at our home. It just we never thought about that thing. But all of you should be very clear. Why do we need a step up at the generator to increase the value of voltage to a very high value so that we can use high tension cable to reduce power losses? Why do we need a step down at the consumer end? Because 100,000 volt is a very enormous value. I strongly believe if, God forbid, we have potential difference of 300 volt at our houses, the all electrical appliances will get burned. Why? Because they are designed for 240 volt. They must surely be having some tolerance. What is tolerance meaning? If a device is designed for 240 volt, you can use it for 220 volt, you can use it for 260 volt or 274. But the thing is, if you increase the voltage beyond the limits, every device will actually get burned, right? So we should know why do we need transformer, and inside our houses, all the chargers, all the adapters that we are using, they have multiple transformer inside them. Now, what is this transformer? I tried explaining the use of it. How transformers work? Transformers actually works on the principle of self and mutual induction. So in easier words, you can say transformer works on the principle of electromagnetic induction. And I hope you remember, I did explain the concept of mutual induction, which is happening because of nearby coil. And I did mention something related to self-induction, which will be happening in the coil whose current you usually change. So transformer works on the principle of electromagnetic induction. How transformers are designed? To design a transformer, we use a metallic frame. This metallic frame is actually three-dimensional. This metallic frame is actually three-dimensional. So to keep things simple, I'm not producing three-dimensional image, but this should be three-dimensional. Okay, let me do one thing. It should be something like this. So this block should be three-dimensional. What we will do? We will wound a coil on one side. So let's say this is one winding. And I'm erasing this 3D part to keep things simple. You can easily visualize them. And this is the other end. This winding is known as primary winding or primary coil. We will supply some input here. That input is alternating, right? That voltage is called VP. VP means voltage provided at primary coil. We take another piece of wire and we will make a winding here. Something like this. And there is no battery. Here we will collect the output. This coil is called secondary coil, and the voltage which is being produced here is known as Vs. One thing is for sure, since primary coil is connected to alternating current source, what will happen? It's a solenoid. When current passes through a solenoid, it produces a magnetic field. When current passes through a solenoid, it produces a magnetic field. So this solenoid will produce a magnetic field. That magnetic field will flow through the frame like this. These are magnetic lines of force which are passing through the frame like this. So can I say this is the magnetic flux? Because what was magnetic flux? The total number of line of force passing perpendicularly through the surface, or the product of magnetic field of induction and area of cross section gives you the magnetic flux. So this orange line actually represents the magnetic flux. So what I can do, I can just mention here that this is magnetic flux. Now, if you people can tell me one thing, will this magnetic flux be constant, or this magnetic flux will be variable or keeps on changing with time?
Sir, variable.
And why?
Because of alternating current, one cycle will be in one direction and the other cycle will be in the opposite direction.
Okay, anyone else who wants to make this answer little more better? See, why this flux should be variable. What Anna said, this will be changing the direction, but most important, this is alternating current. Alternating current keeps on fluctuating. I mean, when it is all positive, even then it keeps on changing the value. Getting it? When it is like this, it will keep on changing its value. So it means that alternating current is fluctuating current, pulsating current. It will keeps on changing its value. When current changes, magnetic field of induction changes. Remember, magnetic field induction of a solenoid is given by B equal mu naught Ni. We use this equation in one of the questions as well. I hope you people have in mind. How many of you remember this equation? Okay, if two remember, all of you will agree, because the day I was explaining you induction, I make reference to this equation. Then in previous class, we were solving questions from past paper, and in that paper, this equation was already given. So since it is alternating current, it will keep on changing its value. When the current changes its value, flux B changes. When B changes, the value of flux changes. And when the value of flux changes, Faraday law says electromagnetic induction occurs. So the flux which is passing through primary coil keeps on changing with time. So induction will occur in primary coil, which is known as self-induced EMF or self-induction. And the induction which is occurring in secondary coil, that is known as mutual induction. So Vs is known as mutually induced EMF. Are you people getting it? So it means that in secondary coil, the EMF Vs is actually mutually induced EMF. So we will provide input voltage at primary coil because of mutual induction. Output is produced at the secondary coil. If I say calculate power of primary coil, so what you can say? Power of primary coil should be Vp Ip. If I say calculate power of secondary coil, you will say power of secondary coil should be VSIS. If I say calculate efficiency of transformer, so efficiency means power output, that is, okay, let me write. Power output divided by power input. This is efficiency. If we need percent efficiency, what we will be doing, we will be writing whole thing multiplied by 100. By the way, which one is output? Power of primary, power of secondary?
Power of secondary.
Power of secondary. Power of primary is input. So efficiency in percentage is given by PS over PP into 100. Now, if I say a transformer is 100% efficient, so how can a transformer be 100% efficient when power output is same as power input for 100% efficiency? 100% efficiency. Now, if any one of you is wondering, sir, the purpose of transformer was to increase or decrease the voltage, so I am sticking to my statement. Purpose of transformer is to increase or decrease the voltage, but it cannot alter the value of power. Can you see? Both the powers are the same, because power means energy per unit time. Energy can neither be created nor be destroyed. So there is no way of generating just 100,000 watts and transferring 150,000 watts. Output power will be less than input power under under real circumstances. If you are talking about ideal cases, in ideal cases when there is no power loss, power of primary and power of secondary will be equal then. So this 100% efficiency is an ideal case. It won't happen in reality. So this is ideal case. Are you people getting it? Yes, Hania, Miram, Alan. Okay, next thing. What factor will decide whether the transformer is step up or step down? See, if you want to have a transformer that is step up, to make a transformer step up, number of turns of secondary should be greater than number of turns of primary. NS should be greater than NP. Number of turns of secondary coil should be greater than number of turns of primary. Such a transformer is step up. And for step down transformer, the number of turns of secondary should be less than number of turns of primary. I mean, by looking at the number of turns, you can decide whether the transformer is step up or step down. For step down transformer, secondary should have less number of turns. And for step up transformer, secondary should have more number of turns. So by looking at number of turns, you can decide this thing, right? And you can establish this relationship very easily. And how can you do that? I mean, under ideal condition, the flux passing through primary is the same as the flux passing through secondary, right? And the EMF in the secondary is mutually induced EMF. If we apply Faraday law for primary coil as self-induced and secondary coil as mutually induced and compare them, you can easily relate this result, but we don't need that working actually. So it is something very easy to memorize. For step up, number of turns of secondary should be more. And for step down, number of turns of secondary should be less. By looking at number of turns, you can decide whether the transformer is step up or step down. Now, the question arises, if efficiency is not 100%, it means that transformer must be having power losses. So what are the sources of power loss in a transformer? Because 100% efficiency is ideal condition, and I mentioned this thing so many times. In real world, ideal means something which will never happen. Ideal means something which will never happen. So we can't have this ideal condition where efficiency is 100%. Efficiency of a transformer will be 90%, 95%. It means that there must be some power losses. And what are the sources of power loss in a transformer? Let's discuss one by one. Number one, if you look at primary coil, you applied voltage to primary coil. So the current will pass through primary coil. Primary coil must be having some resistance. Primary coil must be having some resistance. So some power is lost in primary coil because of its resistance. Exactly the same way, secondary coil must be having some resistance. So some power is lost because of resistance of secondary coil. So number one is power loss occurs because of RP and RS. I hope you remember RP means resistance of primary and RS means resistance of secondary, right? Why? Because when current passes through any material, heating effect is produced, and heat is a form of energy. So from where that energy is coming? The energy you are providing in the form of Vp or in the form of current, some part of it is lost to overcome resistance of the primary or secondary coil. So how can we minimize this? By use of thick wire or thin wire? Yes, how can you reduce the power loss in a wire? Remember, in AS level, we used to study this equation. R is equals to rho L over A. So if we want to decrease the value of resistance, what we can do? You can increase the area of the wire. You can increase the cross-sectional area of the wire. It means that if we use a thick wire, it will be having less resistance, so we will be having less power losses. So how to remove this power loss because of resistance of primary and secondary coil? Use thick wires to make these primary winding and these secondary winding. How many of you are getting this point? Okay, Hani is getting it, Anas getting it, Miram getting it. Yes, Amna and Alan, are you people getting it?
Yes, sir.
Okay, now next. When we reach this conclusion, NS is greater than NP or NS is less than NP, actually we assume one thing which is not part of the syllabus, that's why we didn't discuss. How did we reach this conclusion? We assume that flux passing through primary coil is same as the flux passing through secondary coil, but it will never happen. See why? If I okay, let me write it first. Flux passing through primary is not same as flux passing through secondary. Why? Just imagine it's a metallic frame. It's a metallic frame. When magnetic lines of travel, they will be traveling like this. One line here. On the outside, one line is here. And let's say one line is here. By the way, line of force attract each other, repel each other. Yes. Can two magnetic lines of force intersect each other?
No, sir.
No. Two lines of force can never intersect each other. They actually repel each other. Remember, I quite possible I gave this example. If you bring two magnets close to each other, what will happen? They will repel, and they will repel in a manner, one will move up, other will move down. Because line of force never intersect, they will repel each other. So what is the possibility? Just look at this line of force, which is travel on the very edge of the frame. Can you see? I just draw a dotted line. Unfortunately, you won't be able to. Now you can see it. Can you see here? I draw a dotted line. Quite possible. This is the line of force. Because of the repulsion of other line of force, this line of force couldn't travel on the right and escape from the core. So what is the impact of it? This is the primary coil and this is the secondary coil. Now I hope you will agree. The flux passing through primary is not same as flux passing through secondary. Are you people getting it? Because there could be a line of force that escape the core of the transformer. That core is used for this purpose only, that line of force remain within the core. But nothing is 100% perfect. Few line of force can escape the core. So the flux passing through primary is not passing through secondary. How many of you are actually able to comprehend this thing? Alan, are you getting it?
Yes, sir.
Okay, so what we can do, we change the design of transformer. We actually change the design of the core. For example, let me draw the core first. We use a core like this. And what is the advantage of it? We will take a wire and we will make the winding of primary coil. Then we will take another wire and we will make winding of secondary coil. Now, what you will surely agree, using this technique, primary and secondary coil are actually on top of each other. So what will happen? The line of force passing through primary must be passing through secondary as well. The line of force which are leaving the core will be leaving for both of the coils. Are you people getting it? Okay, if you people are getting it, let me highlight the ways with the help of which we can reduce the power losses. So we discuss about power loss occur because of resistance of primary and secondary. We talk about flux passing through primary is not passing through secondary. Now, the most important thing. See, I did mention one thing. In primary coil, self-induction will occur. In secondary coil, mutual induction will occur. Why induction occurs? When flux passing through a material changes within a magnetic field, what happens? Faraday law says induction occurs and current generate. Now, if you look at this core of the transformer, this core of the transformer is made up of a metal in which magnetic lines of force can travel easily. So induction occurs in this metal as well, and a current is generated in this metal, which is known as eddy's current. When I usually teach this thing, majority of the students feel that eddy means Eddy must be the name of some scientist who actually discovered this thing. By the way, by chance, does anyone of you know what does eddy mean?
So does it mean circulating?
Circulating. Eddy actually means circulation. Eddy actually means swirling effect. What is swirl? You might have seen this thing. This effect is called swirling effect. Eddy means circulation. When flux through magnetic core changes, induced current is generated in the magnetic core. And see, current is basically energy. So this energy is the part of the input energy. So it means that some input energy is wasted in the form of eddy current, because when current passes through the core will heat up, it will dissipate energy. So that energy is a part of input energy. So all the input energy is not going to the output energy. Some part is wasted in the form of eddy's current. So what we can do? If someone say, so use some insulator. So if you use insulator material, line of force won't remain intact within the core. It is needed that we should use a magnetic material, and magnetic material will be conductor as well. So what we do, we use a technique which is known as laminated iron core. Now, what is a laminated iron core? What we usually do, the core is three-dimensional. Let me draw it first, then I will explain. The core is three-dimensional. What we will do, we will divide this core into number of slices. Now, when I use the term number of slices, what does it mean? If you have a bread at your home, you can see a bread is a rectangular block, but you have divided the entire bread in a number of slices. So that is what we are going to do here. We will divide this core in number of slices. And what will be the advantage of it? I will surely explain. Let me draw a few. Okay, it will be something like this. We will divide the core in number of slices. Now, these slices are made up of metal actually. And then what we do, between each two slice, we will be putting some insulator. For example, our insulation layer is placed between these two slices. Okay, like this. Our insulation is placed at the junction of two slices. It's just like in the morning when you have breakfast. You make sandwich of two slices, and between the two slices you can have jam, you can have butter, cheese, and any spread that you like. So we will be doing exactly the same thing. Between two slices of iron, we will be having some insulator. What is the advantage of it? The eddy current which was circulating in the very large loop like this, the eddy current which was circulating in a large loop like this, what will happen because of insulation? That loop will be divided into many smaller loops. Are you people able to understand this thing? If you put some insulation between two metal layers, eddy current won't be able to continue from one layer to other layer. It has to break because of some insulation. that reduces the power loss because of eddies current. So in a transformer, power loss occurs because of resistance of primary and secondary coil. Power loss occurs because flux of primary is not same as secondary. Power loss occurs because of eddies current. One and the last, and this is from where actually I started this discussion, and this is what actually Anas answered. Why in alternating current we have less power loss because of the pulsating value, and he made a reference to that in a half cycle it will be positive and half cycle it will be negative. It's just like if this is a solenoid, if this is a solenoid and current is going this way, so this will be north and this will be south. So let me draw the direction of alternating current. Let's say current is going like this, but the moment current reverses the direction, it means that current will be going this way. So it will become south and it will become north. Are you people able to understand this point? When current changes the direction of magnetic field reverses. The north will become south. The south will become north. How many of you are actually able to comprehend this point? Yes, Alan, Miram, are you getting it? Okay, all of you are getting it. Every material, every magnetic material has a property which is known as retentivity. Every magnetic material has a property which is known as retentivity. What is retentivity? How long the material can maintain magnetic field? Because this is electromagnet, right? When current is passing through it, it will be a magnet. When current is not passing through it, it won't be a magnet. When current changes the direction, it should change the polarity. But just imagine, the coil is made up of metal whose retentivity is very high. So after half cycle, when magnetic field tries to change the polarity, the retentivity of the coil makes it very difficult to change the polarity, because north will want to remain north and south will want to remain south. How many of you actually understood what I said? You can think it like in a, yes, Miram, you want to say something?
No, sir, I was just going to ask you to repeat because I did not get this.
Okay. See what I'm saying. Every material has an ability to maintain magnetic field, right? It just like if you attach a common pin to a magnet, it will remain magnetized for some time, right? So every material has some retentivity. So if we are using a material whose retentivity is high, so what will happen? After half cycle, when north wants to become south, when south wants to become north, then retentivity will resist this change. I'm getting it.
Yes, sir.
It is just like inertia of material. A body at rest wants to remain at rest. A body in motion wants to remain in motion. So what is retentivity? Retentivity is analogous to inertia and magnetic field. North wants to remain north. South wants to remain south. We are using alternating current. We will keep on changing its direction so many times in a second. For example, the alternating current that we use has a frequency of, let's say, 50 hertz. So it will change its direction 50 times in a second, right? So what does it mean? It means that if we are talking about retentivity, we need a material. Okay, you people answer this. It will actually give me an impression where we actually standing. What do you think? What kind of material we should use to make primary and secondary coil? The material, in fact, of the core. What kind of material we should use? The material whose retentivity is very high, or the material whose retentivity is very low?
Very low.
Yes, Hania, Miram, Alan, what do you people think? What material we should use? The material with very high retentivity or low retentivity? I'm waiting for your response.
Sir, I'm not sure.
Hi.
Okay, and Hania, what do you think?
Sir, I'm not sure.
Okay, see, if retentivity of a material is very high, so what will happen? When alternating current change the polarity, magnetic field needs to change the polarity, right? So just look at this frame, this core. Okay, let me explain. Let's say this is the core. During positive cycle, line of force will be traveling in this direction. Let's say line of force will be traveling in this direction. And during the next negative cycle, the line of force will be traveling in this direction. Actually, if you focus, directions are opposite of each other. Directions are opposite because here this direction is upward and here this direction is downward. Are you people getting it? When magnetic lines of force are passing through core of the transformer, when alternating current changes the polarity, the direction of flow of flux should reverse, right? But what if the retentivity of this core is very high? So it will take a lot of effort to change the direction of magnetic field. Is it making sense now? Yes, Alan, Hania, Mira. Okay, Hania is getting it. Mira, I'm still confused. Okay, Mira is getting it. Alan, okay, all of you are getting it. So what kind of material we need? A material whose retentivity is very low. The moment alternating current changes the direction, the block of the transformer changes the polarity of it. So we need a material whose retentivity is very low, and all magnetic materials, a good magnetic material have high retentivity. And when metal doesn't fulfill your requirement, what do we do, by the way? I mean, if we need some metallic material, but that is not fulfilling our requirement, what we do usually? If you are taking chemistry, you can answer this question easily. For example, we have stainless steel, right? Okay, forget about everything. In cars, Anas, you want to say something? Yes.
So I think you're talking about alloy, mixture of
Alloy.
metals.
Yeah, exactly. When metals don't fulfill your need, you actually made the alloy so that you can have all the characteristics you want. For example, in cars, we have wheels. Those wheels should be very strong. Those wheels should be very tough, right? So if we make them of pure iron, they will be so heavy that it will be very difficult for the motor of the car to turn those wheels. So what we did, we make alloy, and that alloy won't get rusted. Those alloys should be very strong. Stainless steel. If you make a spoon of just iron, if you make spoons of iron, what will happen after one wash? It will get rusted. Do you agree? Right? So, by the way, do we know steel is alloy of which metal?
Carbon and iron, I guess.
Basically, it is alloy of iron, and we add carbon, manganese, and some other material in it. But what is important? Just see, if we talk about iron, You just put iron in water, it will get rusted. But if you look at steel, and you will be surprised when you make steel, it's not like you put 50 or 60% of some other impurity in steel, iron. That I don't remember exact composition, but one thing is for sure, it must be containing almost 100% iron only. It will be having 1 or 2% of some other elements, right? But how properties changes? It won't get rusted when you make steel or stainless steel, right? So when metal doesn't fulfill your requirement, you make alloy. So all the good magnetic materials, because if you can relate, use of good magnetic materials are neat so that flux is more and more within the core, and a good magnetic material will be having a high retentivity. So we need a material which is magnetic as well as has less retentivity at the same time. So we designed an alloy. That alloy is actually known as perm alloy. That alloy is actually known as perm alloy. So when we talk about the frame of transformer, these frames are actually made up of an alloy. That alloy is, it is an iron alloy actually, right? And this alloy is known as perm alloy. The advantage of perm alloy is its retentivity is actually very low. Its retentivity is actually very low. Since its retentivity is very low, there won't be enough energy loss for the change of polarity. By the way, the energy loss which is occurs because of change of polarity is known as hysteresis loss. This is known as hysteresis loss. Quite possible. You remember the graph of, remember that stress and strain thing you might have studied in AS level physics. If we look at the graph of rubber, this is expansion, this is compression. That graph is something like this. How many of you remember this graph? Okay, almost all of you remember this. This gap was the basically loss of energy, and this is called hysteresis loss. This loss was actually hysteresis loss. This is actually the shape of a curve. So in transformer, some power losses occur because of retentivity. That loss is known as hysteresis loss, and this loss can be overcome by using an alloy which is known as perm alloy. This loss can be overcome with the help of an alloy which is known as perm alloy. Because in exam, they do ask questions related to sources of power loss in a transformer. How can you minimize them? So I'm just giving you 2 minutes. Just go through whatever we have discussed. If you have any question, it's fine. Otherwise, we need to solve at Okay, all of you are trying to solve this question. Once you are done solving it, raise your hand. We will discuss the answers. Meanwhile, I will upload a question on Google Classroom that you will be solving. Okay, let's discuss the answers for this question. Explain what is mean by the root mean square value of an alternating voltage. Remember one thing. It is VRMS, it is IRMS. These two values are basically direct current or direct voltage values, which are equivalent to alternating current. So when they say explain what is mean by root mean square value of an alternating current, so what you can say, the RMS value of alternating current or voltage is basically the direct current or direct voltage, which converts electrical energy in other forms in a given resistor at the same rate as the alternating voltage. Because the problem with alternating is it keeps on pulsating, and we can put one value in the equation. Whenever you put one value, it means that you are actually not talking about their variable nature. That's why RMS values are DC values, or in fact, direct values. DC means direct current or direct voltage. And alternating voltage is represented by the equation 220 sine 120 pi t, where V is measured in volt and T is in seconds. For this alternating voltage, determine the peak voltage. So this is the peak value, 220 volt. The RMS voltage, remember, RMS voltage is given by V naught over square root of 2. So 220 over square root of 2. So if I simplify this, what I will be getting?
Sir, 155.56.
So can I say this is just 156 volt? The frequency. Those who have studied oscillation with me, they will surely agree. This is actually, this factor is actually like sine of omega t. So it means that omega is actually 120 pi. We know that omega is given by 2 pi f equal 120 pi. Pi and pi will get cancelled. So if I calculate the value of frequency, you should be getting 60 years. By the way, how many of you actually got the same answer for these three parts? Yes, Alan and Miram, are you getting it?
Yes, sir.
Okay. The alternating voltage in B is applied across a resistor such that the mean power output from the resistor is 1.5. Calculate the resistance. See, this is the mean power output. Mean means they are talking about average. And remember, in A2 physics, average is denoted by this symbol. So average power will be VRMS square over R, because power is actually V square over R. We need mean power, so we need to use RMS value of the voltage. So VRMS square over R, what is the value of VRMS? 156 square. What is the mean power? 1.5 kilowatts. We can easily calculate the value of R. So if I simplify this, what I will be getting?
16.13.
16.13. Since this value is in two significant figures, so 16.13 can be just written as 16 ohm. But if you mention 16.2, it will work. But it's better to take care of significant figures. Okay, if we are done with this question, Okay, try to answer this question. Once you are done with it, let me know. We will discuss the answers. Yes, Alhamdulillah. Still solving? Okay, let's quickly discuss the answer. A simple iron core transformer is illustrated in figure 6.1. State why the primary and secondary coil are wound on a core made of iron, so that the flux passing through primary also passes through secondary, or you can say to maximize the flux linkage. Suggest why thermal energy is generated in the core when the transformer is used, because flux through the core changes, eddies current is produced, and current produces heating. You can make reference to energy equal I square RT. The root mean square voltage and current in the primary coil are Vp and Ip. The RMS voltage and current in the secondary coil are Vs and Is respectively. Explain by reference to direct current what is mean by root mean square value of an alternating current. So it is the same thing. Root mean square value of alternating current of voltage is the steady direct current of voltage that will cause energy dissipation at the same rate as that of alternating current. Show that for ideal transformer, Vs over Vp equal Ip over Is. Did you people prove this thing? Because we did discuss this thing here. When you say PS equal PP, because 100% efficiency means power of secondary and power of primary are equal. So it will be Vs Is equal Vp Ip. So you can easily say Vs over Vp equal Ip over Is. So we will keep it till here only. In next class, we will be discussing rectification, and hopefully in next class we will be able to complete this portion as well. Okay, so I will resume from here in next class now.